Okay, good. Okay, so this is what you guys need to do. Okay, you guys need to pull up the screen with the instructions. Okay, what you're going to need your empty water bottle. You're going to need Kool-Aid. You're going to need baking soda. And you're going to need water. Okay, so for the first part of the experiment, and your conical tubes. Okay, for the first part of the experiment, hold to the side because you're also going to need it later on, but hold on to the side. You're going to need your litmus paper, your pH paper, and your what's it called? Your indicator. Yes, your cabbage indicator. Okay, that's to the side. You want to put that to the side. Okay, so what you guys are going to do is you're going to need to follow the instructions. Get your Kool-Aid, and you need to measure out. I believe it's. Take a look. Hold on.
50 milliliters of water, I believe. Yep.
First, do the Kool-Aid.
Oh.
What does it say? Kool-Aid first, right?
Oh, half a teaspoon.
Okay, so you're gonna half a teaspoon of Kool-Aid.
Put in a conical. Okay. Give me the teaspoon.
I'm trying to look for the instructions. Hold on. It's not in grades, right? It's only going to be in modules.
It'll be under, yeah. It won't. Yeah, actually, it would be.
Yeah, I can't find it either.
Because it's not showing up. It says no preview.
Oh, give me 1 second. Let me find out why.
It's because you're going through the grade site. You can't go through the grades. You have to go on modules.
You see it on modules?
Yeah.
Okay, I'll go that way.
Just go Control F and put lab 10, right? Or what is this? Lab 12?
12.
Yeah, put Control F.
Oh yeah.
Take you right to it.
You're smart.
Some days.
Lab 12.
Wait, isn't this lab 11?
Yeah.
It's under lab 12 under modules.
Well, in grades,
11 mole molarity.
In grades.
Calculations.
No, we're doing acidic something.
We're in lab 12. Determinate
12, definitely.
determination of unknown amount of citric acid.
That's two different names.
Citric acid. There we go.
If you're in Harnell, it's the molar. It's the molar part, and then in Kalinga, it is determinant of citric acid. Basma, can you hear me? Can you go to my office hours?
Who?
So for Hartnell is lab 11, right?
Yeah, he has us divided,
Okay.
not united. We're not united.
Okay.
Just gotta find it though. Lab 10. I try to do the Control F.
Dr.
It's not
Henry,
with me
do I
today.
put the Kool-Aid in the bottle that it's already filled with the water, or
Where the heck is this?
No, you're gonna put the Kool-Aid. You're gonna put the Kool-Aid in the empty bottle, right? So what you're gonna do is you're gonna put the Kool-Aid in the conical tube, and then you're gonna fill it up to 50 mils, and you're gonna put that in the bottle. Well, you're gonna mix it and then put it in the bottle.
Okay, so I just put it here, the one with the water?
No, don't put it with the one with the water because you're gonna use the water for something else.
Go
Okay.
step by step.
Cool. You put it in the column. Okay.
Put it in an empty conical tube, okay? And then you can fill it up with just regular water. That's fine.
With water.
Dr. Henry, I
What
got
does
a
the
conical
instructions
tube
say, Brianna,
full of distilled water.
excuse me?
Dr. Henry, it's Heather. I got this. It came with water in it. Could I use it?
No, you're gonna be using that for your cabbage, your cabbage indicator.
Oh, okay, hold on.
Empty
So you
water.
can just use regular water.
Put it in-
The other part.
All right.
Okay, so let me,
I feel like drinking it.
okay, so is everybody on the same page right there? Let me go handle the other guys real quick, okay? Get them started. I'll be right back. So you guys can help each other mix the Kool-Aid? Veronica?
Yes.
Okay,
Yeah.
that's what I want to hear.
Yeah.
So add 50 milliliters of water to Kool-Aid solution, okay, and then you mix. Wait, what?
It then.
So
Yeah.
wait, are we adding the Kool-Aid to the conical tube or the bottle? Because
To add it to the conical tube with the Kool-Aid solution,
You add it to the tube with the solution and then you dump it in the water bottle.
and then you add another 50?
Wait, I'm so confused. I had to leave for a minute. Now I'm lost.
Okay, can we start from the beginning? Sorry.
Yeah, we just finished the whole lab. You missed
Oh
it.
shit. Oh well, I failed. Okay.
So put a teaspoon of Kool-Aid on your tube right here and then fill it
This
up to
big
50
conical tube?
ml.
Half a teaspoon.
Half.
Half a
Put it up
half a-
to,
teaspoon of Kool-Aid.
fill it up to 50 mLs. Then once you mix it, you put it in your water bottle, your empty water bottle.
So you want me to get normal water and a teaspoon of Kool-Aid?
Half a
Half a
teaspoon.
teaspoon.
Okay, half a teaspoon.
Yeah,
Put it together.
put it in here.
What the? They didn't even send me any Kool-Aid in this packet.
I know there's like hardly anything.
it's so concentrated. I took
Wait,
not like
no,
it's
like
exactly-
they're literally. Is this how they make Kool-Aid these days?
I guess.
That was it. There's
2
like
cups of
literally.
sugar, probably.
Oh, mine.
They don't buy Kool-Aid, so I don't know.
You're not a 90s kid.
It's not even like half a teaspoon. It's like 5 little grains.
Damn, they ripped
Say
you
cheap
off, didn't they?
They rip you off, for sure.
I'm pretty
Dollar
sure.
Tree.
Pretty sure Dr. Henry said he bought all this stuff for $50. I don't know where he's buying it.
He bought your guys' all of your guys' ingredients?
I think that's what he said in the last class. He spent $50 on everything. I
Must
was
be
gonna
that.
ask him about that.
Must be
I
nice.
got
We had
milk.
our-
Somebody has to buy
I
this.
got my own.
We're adding 50 milliliters of water or 100?
50 and then plus another 50. That's what I'm getting. So yes, 100.
Yeah.
Okay.
So once we mix it, we put it in the water bottle.
That makes
Um,
sense. Your guys' like solution looks like really light.
Wait,
Mine's like
so
dark.
you guys are saying, how many packets are you using?
Just one.
Half a teaspoon is just 1 packet.
It probably looks lighter because it depends on the flavor you get, I think. I don't know, you know?
Half a teaspoon
Right
is
there.
one packet?
Oh.
So little tea is a teaspoon, right?
Yeah, TSP.
No, just tea, little tea.
Hey guys, I don't have my measuring cups, so I'm gonna go buy some real quick. When I come back, can someone help me out with the lab, like from the start?
Don't go buy them. Just measure out a little.
Yeah, I can help you, Keila.
Okay, thank you guys.
Big tea is tablespoon, right, guys? And little tea is teaspoon, right?
Yes. Right.
Okay, definitely didn't even have enough in these 2 packets to fill half a teaspoon. I'm gonna try a 3rd packet.
Thank God you got more than one, Heather.
It says it makes 2 quarts. I just really don't know how flavorful these. I mean, it's Kool-Aid, name brand.
So after we have this, then we add another 50 ml to the.
That's what I'm understanding. It says you add water to bring up to 50 solutions conical tube, and then you add it to the empty water bottle. And then you add another 50 mLs of H2O to.
Yeah, I added 100 milliliters of water. So
Yeah, and then mix well.
Okay, so now the Kool-Aid goes inside the empty bottle, right? Kool-Aid
Yeah.
goes in there? Or do I put in the conical tube
Or wait, no,
first?
the conical
no, no.
tube, and then
It
add
goes in the
50.
conical tube, yeah. The Kool-Aid mixture with the water goes in the empty bottle.
All
Where's
right.
Dr. Henry? He left us hanging.
You
Yeah,
wanna
be
go help
careful,
out the
guys.
other group?
Be careful because there's a part where it gets to soap or something and baking soda, so don't skip that or something. Like there's like an order or something. He'll make you redo it. So
Alright, I got
this goes
packets of
the
Kool-Aid.
Oh my God, we're already calculating. It says for step 6, calculate the percent mass of Kool-Aid for
Oh,
solution.
gosh.
For solution 1, use the density of water.
So now I put the powder in the conical tube and I put 50 milliliters of water, right?
Yeah.
Yes.
So in reality, it's gonna be 100 milliliters of water.
Yeah.
So once we
Yeah.
have it in here, do we put 50 mLs more of water?
Yes. Yeah.
Okay, so 50 milliliters of this.
So now it wants us to calculate the mass of Kool-Aid for solution 1.
And now I pour this inside the bottle, right?
Yep.
Okay.
Wouldn't it just be like 100 milliliters?
Yeah.
I don't know why we couldn't just do 100 from the beginning.
Probably because the conical tube doesn't have, I don't know.
10 meters of solution. Is that the distilled water thingy?
So another 50 ml of water.
Yeah.
Solution to 1 conical tube. So then we just add 10 milliliters to the 1 conical tube
Yeah, but what's the solution? Oh, of this
of
right
the mixture.
Oh, okay.
Now we have 100, we just need 10 of them.
So add 10 milliliters
Of this? Looks like this.
Yes,
Okay.
to a conical tube.
Oh, look at the.
Which conical tube are you guys using to put the Kool-Aid
50 ml, the big one,
The big one? Gotcha.
empty
After
one.
the 100 one, do we add another 10?
No, we pour 10 of that 100 into the conical tube.
Oh, okay.
There you go.
So he wants 10 milliliters of this into this.
Yeah.
Into the little conical tube, yep.
Yeah, that makes sense.
And then you add 2 drops of dishwashing soap.
Dish soap.
Yep. 2
Oh
drops.
shit.
You're gonna make a mess.
I could, the foam.
So
I don't think so. I think it's supposed to be acidic.
Yeah, but if you do it wrong and you may have to have a dissolution or something like that, he said, then you'll have to add soap. So you'll know what if it overflows past your conical tube.
Hey guys, where are you guys seeing the soap part? Because I don't see it in the instructions.
it's number 8.
Mine says add 1/4 of teaspoon of baking soda.
On top of that, before that,
It says add 10 mLs of solution to 1 conical tube.
Oh, he didn't
Oh,
put
you're
the
missing
dishwashing
step.
soap. Yeah.
Step
So put 2 drops of dishwashing soap.
So do you guys already calculated the percent mass of Kool-Aid?
No.
I don't think we calculated it, but I think it's just 100 milliliters, right?
I think so.
100 milliliters is for both the Kool-Aid and just the water added to it. So they're just asking for how much you add for the Kool-Aid, which is the 50 milliliter.
So 6 would be 100, you said?
Yeah,
Calculate-
that's what I'm doing.
Oh. Oh my god. Is it supposed to like overflow like this?
Hey guys, so since my steps are different,
Oh my gosh, why do you have so much?
after we do the add 10 mLs of solution to 1 conical tube, how many drops of soap do I have to add?
2.
2 drops?
Yeah.
I'm gonna go ahead and share my screen. Maybe
Oh,
we can see the
Wait,
same-
Veronica, did you already add the baking soda? Why is yours like
Why
puffy?
is he not on our screen to help us?
Hold on, somebody's moving something.
Yeah, she added the baking soda already.
Okay, so add 2 drops of dish soap. Okay, let me add 2 drops of dish soap.
Yeah.
Oh my goodness.
So after the dish soap, then we do the baking soda?
We do 1/4 of a teaspoon of baking soda.
Oh, mine says what?
2 drops and add 1/4 of teaspoon of baking soda. 1/4 teaspoon.
It's not supposed to go over your guys' conical tube. If the foam goes over it, you have to redo it.
Okay, and so if it's like, it just went over like that, it went like literally to 50 ml.
Because he wants you to measure the peak and he wants you to measure the low part when it settles. So if the peak at any point went higher, then it's wrong. It shouldn't go over the 50 ml. Because it'll mess up your end
Writing
result.
down the peak?
Huh?
Are we writing down are we supposed to remember where it peaks?
Yeah, I think so. From what I watched that 2-hour video, but
2-hour video.
yeah, it was his last class, the AM one. And you guys we have to do it 3 to 4 times over again.
Fuck.
Yeah.
Okay, so my first one went to 45 milliliters.
So we measure after we put the baking soda?
After it stops, right?
After it stops.
Do we shake it or anything?
No.
Oh shit. It's gonna fucking.
But if it goes over at any point, you have to redo it.
No, don't go over, don't go over. And it maxed out.
Yeah. So you have to restart it. But the thing is that you have 100. Yeah, that's right. We have 100 of this solution to work from to do the 3 or 4 trials out of the bottle that we need.
Well, in that case, we don't have to like restart with like making a new solution and everything. We could just
No.
Hey
Yeah.
guys, if it stop at the
But I mean,
50
regardless, you still have to do 3 or 4 trials period, I think.
Oh, okay. So no, even if it stopped at 50, you still have to redo it like 3 times?
No, if it stops at, yeah, if it stops at 50, that's fine. But if it goes over, and either way, you still have to do 3 or 4 times because I think he wants you to make sure that it's accurate.
Okay, and then we measure once it stops foaming, correct? When it starts.
Yeah.
Foaming? Okay, thank you.
Yeah.
So my first one went to 45.
Okay, so then you'll log that 45.
So once you put the basic baking soda, it's supposed to go up?
Yeah. Yeah, drop it in the sink.
Mine didn't even go up.
You add the soap?
Yeah,
Oh, did you use Kool-Aid?
yeah.
And
10 mLs of water.
Yep.
what kind of water did you use?
Is it
Just
the
regular
the regular water bottle?
Sink
Okay.
water. Do sink water.
Because it depends on the level of the acidity, I guess, or like the pH, sorry, the pH balance. That might affect it. So distilled is the better option if you have that in your house. I'm not using it because I'm too lazy to go to my pantry. But
Okay. And then we do another 1/4 teaspoon of
So I should just do like sink water, huh?
yeah, you could try to your next couple times might be better.
I did
mine-
sink water, Daisy.
Mine went up to like 38. Is that okay? Or?
Mine's went up to a 30. Is it supposed to look like this?
Yeah.
Yeah.
Okay.
Oh crap! Here, throw that away.
Hey guys, do we measure where the foam stops, correct?
Yes.
Okay, thanks. Let's stop at 50. And we can just move it out and redo it again?
Yes, you want to repeat it. So once you get the right concentration, so the key is, I know it's not clear here, but you want to try to find the right experimental procedure so that you can calculate how much citric acid you have in your solution, okay? And so the first dilution will actually, it should work, but it may go over, right? Just depending on how heavy you were with your half a teaspoon.
See, mine didn't even act. Mine didn't do anything. Did I do something wrong?
Yeah, same here. Mine didn't even act at all.
You had nothing happened at all.
No reaction?
Not mine.
Okay, so let me make sure that you guys did this correctly. So, you put your Kool-Aid. You have your Kool-Aid?
Yeah.
Okay, so you put your Kool-Aid initially in 50 mils of water, right?
Is it
Yes.
supposed to be like sink water? Because I use water, and Heather suggested I use like something else.
Water is fine. Sink water is fine. You can use bottled water. It doesn't matter the water. The water isn't going to make too much of a difference. Okay, so then you put in another 50 mils of water, and you put that in your empty water bottle. Is that correct?
That's gonna be 100.
Okay, so that's gonna be a total of 100. That's correct. Okay, so then you took 10 mils of that and you mix it all nicely, and you put that into the conical tube. Is that correct?
Yeah.
Yes.
Okay, then you added 2 drops of dish soap.
Yes.
Yeah.
Okay, and then you added a 1/4 of a teaspoon of baking powder.
Yes.
Yeah.
I mean baking soda, not baking powder.
Yeah.
And nothing happened?
No,
Nothing.
not mine. Didn't do
Okay, so-
anything.
Nothing happened on mine either.
Tell me about your Kool-Aid.
Huh?
Tell me about your Kool-Aid.
My Kool-Aid, I put half a teaspoon.
Okay, what type of Kool-Aid do you have?
Kool-Aid, I don't know. I don't buy Kool-Aid, but it's this.
Okay, so
That's Kool-Aid.
your problem is that one has sugar. Does that have sugar?
You broke off. What happened?
That one has sugar in it, right? So you got the big kind that already has the sugar in it. What about you, Wilmer? Which Kool-Aid did you
Yeah.
buy? Did you buy the same one that she bought?
Mine has sugar in it.
Okay, so that's the reason why yours isn't working. You guys need the little packet of Kool-Aid that has no sugar in it.
Like this one.
Oh, sugar-free?
Unsweetened.
No, just the little packet ones, the ones that are concentrated.
Like this, right?
You guys got fancy. You got the expensive, the rich kid Kool-Aid.
Didn't you get us this stuff or no? I forget what I bought anymore.
I don't.
Henry, does
Yes.
like 40 milliliters sound about right?
What was that?
Does 40 milliliters sound about right when it goes up?
Yeah, it should be about 45, 40.
Okay,
Between 45, 35 to 40, somewhere in that range.
all right, sounds good.
Dr. Henry.
What if it stops? What if it stops right at 50? Because that's what I got.
Okay, long as you can repeat that 50 3 times, then you're good to go. If it goes over,
Number
then-
3 times.
3 times. You got to repeat the experiment 3 times.
So my second one stopped at 50 as well.
Okay, so then your first one was at what?
At 50.
Okay, so then
And
do it
this
one
one
more
too?
time. Yeah, do it one more time. So you want to be able to repeat it. So the thing about science, right? It needs to be repeatable. You need to
Kobe,
repeat it 3 times.
you got Kool-Aid? Those packets?
So do we just like dump this out and then refill it, Dr. Henry?
Yep, you dump it out and refill it. Yep. Yeah.
Dr.
What
Henry,
if-
what if for one I got 45 and then this one got 42, 42
fine.
and a half?
That's fine. So, but the thing is that then you're going to take the average, to kind of give us an idea, because it's going to be somewhere in that average. It's okay if it's not perfect.
Got it.
But if
Dr.
it goes
Henry?
over, that probably means that you need to dilute it down. Okay. Yes, somebody, Dr. Henry.
Me,
Dr.
I did.
Henry?
Heather, do I need to dilute it some more? Because it went up, but it barely went like right here to the top.
Okay. Was that your first attempt or was that
Yeah.
your second attempt?
My first.
Okay, so do it one more time. And if it goes over the 50 mark, then you're not able to, you can't figure out what it is. You need it to be within the range of the conical tube. You're limited by the range of the conical tube. Do you
Doctor,
So
understand? Yes.
my first attempt, it went like over. Can you walk me through how to dilute it?
Okay, so yes, I'm going to give you a different dilution that's on there to make it a little bit clearer and a little bit tighter. Okay, so what you're going to do is you're going to take 5 mils of your Kool-Aid
40.
and then you're going to put 5 mils of water. So then that's a half a dilution, right? And then repeat the experiment.
I don't get it. What do you
Daisy.
mean 5 ml?
Huh?
5?
I saw that. I saw that. What happened there?
I was putting the water in the Kool-Aid.
Okay,
So Dr. Henry, I got all three tries at the 50.
okay, so then you're good to go. So you want to record that as your volume. That's going to be your volume. Okay.
So Dr. Henry, I added a whole teaspoon and it activated. So
Okay.
I got 45.
Okay. So what you need to do, so you need to take in consideration that you guys have the super diluted because you have a lot of sugar in there. So you did exactly what you needed to do. You put a full teaspoon in there. That works out great. Okay.
Yeah.
Okay.
So are we measuring the peak or like, so if it goes all the way to the top, it's 50 ml or what?
Yeah, if there's a line that shows you where the 50 mark is, it's a perfect little clear little line. That's your 50 mark.
And then, so that's what we're recording, or we're recording
Yes.
where it went down?
No, you're recording the peak, the top,
Okay.
the max.
Okay, I'm gonna redo it again with regular Kool-Aid. Found some with no sugar.
Okay, that gives you the best result. You have to go be fancy and rich. So you obviously have a good job.
Well, I really don't ever buy this stuff, so I just grab whatever, you know?
Yeah, so I'll make sure to say the packets the next time.
Yes, please. Okay.
I'll be right back.
But it went up super high because it still had baking soda in my tube.
Yeah, mine's overfilling.
Okay, let me start it from the beginning. At what point do we use the cabbage thing?
Oh no, my things are already went up. Shit.
What I did was you know how I think you told one of you guys to put like 5 ml of the Kool-Aid solution and then like just 5 ml water and it'll kind of tone it down in a way. So that's what I did, and now I got a lower peak.
So 5 instead of 10 for all three then?
Yeah. Dr. Henry, I have a question. Okay. Hey guys, I know I asked this question again, but do we have to wait till like it completely stops, or?
Yeah, because then it's gonna start going down. Yeah.
Oh, well, then they're all gonna be the same then, 10.
Yeah, they're all gonna be 50. If you got them all like off 50, that's what he was saying. Like if it's 50, then that's when we know it's good. If it goes over 50, or if it's like 150 and the other one like 30 or so, then you know you have to get.
Yeah, but I know someone said that we have to measure the after result. So when the foam goes down, do we measure that? That's what I'm saying.
That's true.
I thought it was just the like measuring.
It was just yeah.
He just said the peak.
Oh, okay. I'll cut it out. He said he was gonna go over the math part, right?
Yeah.
Yes.
So, okay, so 3 times.
Yep.
I have a question. So for our equation, are we just using the highest volume that we got?
We're going to use the average of the 3.
Oh, okay. Thank you.
So if 50 was ours, we're gonna use 50.
Yep.
I made a big mess with the second one I did. Oh my God.
So if our solution is too strong, we add 50% water and 50% of the solution every run we do.
I think he did mention that.
Because my solution was way too strong too. It would kind of do its thing and overflow. So what are the things that we're writing down? Just the volume?
The 3 volumes so far.
So would it be said if it overflows, what do we have to do?
You have to redo it.
Okay.
You have to dilute it if it keeps on overflowing.
Okay, just overflowed it one time. Okay. Now I'm a big mess. Okay.
But again, Daisy, it might not overfill this time.
Oh, this last time I didn't.
Oh.
Yeah. The second time I did it, I made a huge mess the second time.
if any of you guys are doing like the half and half solution, is yours like now really like, is your highest peak like really low? Because mine is 35 now.
Mine goes like that too.
Oh,
It goes down because mine's going down.
yeah.
Mine's about a 35 as well.
Like after the foam, like it's up to 30, and then the rest is like pure foam.
I got 250s.
Yeah, because
Yeah.
at first I was getting a little over 50, so that's why I started doing the half and half solution, and now I'm just getting like the 35.
Yeah, everyone's saying it's like 40 to 45, but I'm doing the half solution too, and mine only reaches up to like 30 to 25.
See, because mine reached up to 50, and now it's like at 45. It's like slowly going down.
Yeah, but we don't have to measure those.
Oh no? So
No.
it's just 50 and that's it, right?
Just 50. That's what someone said, right? That's what I was asking earlier.
Yeah.
Oh, I hope
What?
you guys, we don't have to measure the when it starts dropping, right? We just have
No,
to
just when it measures.
Just the peak, he
just the
said.
peak, not the-
Yeah, I thought it was both, but he just said that.
Okay.
Said that the range would be like 35 to 45 or like 50, right? Just to make sure that.
So he said if you got all 3, like 50, then it's 50. I'm keeping it 50. That's what I got.
I got 2 at 50, but you want
So the average.
average, yeah.
Yeah. So at what point do we do the cabbage powder and?
I don't think we're gonna do that anymore.
Yeah, we are.
We are?
I think because the other class did it. Did he say we weren't gonna do it for ours?
I don't see any instructions for cabbage powder.
I don't see anything that says cabbage powder either.
You said that
Oh.
we would do it after this part.
Oh, there it goes. There it goes.
Okay, now the bottom part of the lab says something about vinegar. Determine the pH of your Kool-Aid vinegar, 5 milliliters, and baking soda.
What number is that?
That's like the last part underneath the picture. And then under that, making a indicator,
Oh, okay.
it says determine the pH of your Kool-Aid and vinegar. I'm just like browsing through it.
We're in the bottom.
Daisy Guzman, I got the same as you, 350s.
Oh yeah. The second one I did it went, but then I did it again. See, and now it's already down and it's to 35, but at the beginning it was 50.
Yeah.
See?
Yeah. Yeah. So 350s.
I have a
Hey, Diana.
But I think with one of these, don't we use that little indicator?
Real quick.
Oh my god, I just dumped it out again. Oh my, okay, let me do it again.
So I think the last one we used the foam for the indicator. So maybe just wait on, hold on to your last one.
My foam just went all the way down.
Wait, were we supposed to dump out our conical tube?
No, I just had to redo mine again because I did.
Hold on to your last one because I think we use it, the foam part.
We do?
I think we do.
Let's see.
This is like my 5th one.
So we do need one, so I can go ahead and do it again.
I know, I just redid it. Because we're waiting for him to go to the next step.
Keeping them on pushing. What they to say, just changing your concentration of Kool-Aid.
Calculate mass percentage of Kool-Aid for solution 2 and solution 3. That's number 20. Is that the cabbage part?
I don't know.
50 again. Okay. I'm still a little confused as to what we're supposed to be recording, like writing down.
Okay, so first you write down number 6, which is calculate the mass of the Kool-Aid, mass percent. And then you're gonna record your 3 highest peaks.
Did you
And
guys
then-
write 100 on number 6, like the math?
Yeah,
Yeah.
yeah.
Okay. I did too.
And then your average, you want the average of your 3 your 3 peaks. And then the average volume. And then I guess we're at 20. Calculate mass percent of Kool-Aid for solution 2 and solution 3.
Hey, Kayla, can you hear me?
Yeah, I can hear you.
Okay, so you have all your stuff?
Yeah.
Okay, so get the little tube and fill it up to 50. I mean, first put where is it at?
Teaspoon.
A teaspoon, a half a teaspoon of the Kool-Aid in it.
Put it in the water bottle or?
No, in the little tube, this little guy.
Oh, you're right, you're right. Okay.
So put 50 mLs. Well, actually, first put the Kool-Aid and then put the 50 mLs.
Okay.
So the Kool-Aid is going to be a half a teaspoon.
Okay, half a teaspoon of Kool-Aid, and then you said what's next?
And then put 50 mLs of water, pink water.
Give me a sec, I'll be right back.
Mm-hmm.
So for number 6, it says calculate the percentage mass of Kool-Aid. I went up and it said percentage mass equals mass of solute divided by mass of solution times 100.
All right, Diana, put the 50.
Hold on. Where's your screen?
Mass of solute, which is 2.5 grams. Divided by mass of solution, 100 grams.
So is the solute, that's what I'm thinking. Is the solute
Kool-Aid,
what?
yeah,
Yeah,
so
the
it's
Kool-Aid. And then
percentage
the
of mass
solutions-
equals 2.5 grams.
So he had everyone looking on their Kool-Aid packages to see like where citric acid was at, and
It
if
just
it's
says
the
mass
first ingredient, then that means
It just says mass of
means it's
solute.
mainly
So it's 2.5.
yeah. So
because
so 2.5.
you know what I mean? So number 1 says measure out half a teaspoon, 2.5 grams of Kool-Aid. So then at the top, if you scroll up, it says the percentage mass equals mass of solute, and in parentheses it says Kool-Aid, so that's 2.5 grams divided by mass of solution, Kool-Aid and water, which is 100 grams, right?
Mm-hmm.
Or is it? Yeah, because he wanted us to put it up to 100 with it in it. Times 100 equals 2.5%, right?
Wait, did we add at that point the soap or no? Oh no, soap we don't take into consideration the soap, huh? It says
No, we didn't add
solution.
anything.
It says solution 1, use the density of water. What's the density of water?
1 gram over ml.
Yeah.
So calculate the percent mass of Kool-Aid for solution 1.
So isn't that, and if you scroll up, it says percentage mass equals mass of solute divided by mass of solution times 100.
So that is 2.5.
So 2.5% mass, right?
That's about right. Mm-hmm.
So that's number 6.
Okay.
If you're converting decimals to a percentage, you just times it by 100 because it just moved 2 to the Right.
2.5 times
What did you
100.
guys get for 6? Like
No.
the answer.
No,
That's what we're talking about.
2.5 divided by 100. Mass of the solution is 100. So 2.5 divided by 100.
Is 0.025 times 100.
100 is 2.5.
Is 2.5. Yeah, you're right.
Wait, where'd you get the 2.5?
Wait, I get
The
0.
grams.
The grams. So if you go to number 1, it says measure out half a teaspoon. And in parentheses, it says 2.5 grams of Kool-Aid. And then scroll, and so the percentage mass, if you scroll up, it says mass of solute divided by mass of solution times 100. And that's number 6, which is percentage mass.
So it'd be 2.5 divided by 100,
Yeah.
right?
Times 100.
So that's just 2.5.
2.5.
Oh, okay. I'm missing a step. Let me see. Duh. I was like, wait, I don't get that. Okay.
So where does the density of water come into play?
To convert it to milliliters to grams. That's
Yeah.
So convert the 2.5 from grams to milliliters?
Mm-hmm. So then it says number 20. Calculate percentage mass of Kool-Aid for solution 2 and 3. Does it say measure does it say do the measure of volume? Or mass.
I go to school, you go to school.
21 says record both percent mass and percent mass volume for solution 1, 2, and 3.
So then it says calculate the percentage mass of Kool-Aid for solution 2 and 3.
Wouldn't it be the same because we're using the same measurements?
Or are we supposed to be using our 45 or our average number?
Isn't that our volume?
Oh, that's the number 21.
I think it's from the conical tube that we measured.
Is that number 20?
Yeah.
I'm still stuck on 6. So it's 2.5 ml, right?
Yeah, so it's
Right.
0.5 grams divided by 100 grams equals or times 100.
Right. So then it comes out to 2.5 grams, right?
Yeah.
And then we got to convert that to milliliters, which is 2.5 ml.
No, the only thing we were converting was the water.
Yeah.
Oh, okay. So just 2.5 grams.
Yeah.
Yeah,
Okay.
just a 2.5.
Yeah. Oh, I was like, there's a fire behind you, but it's your bonfire.
No, my husband's doing hamburgers for the kids and he probably burned them. Or something. Or he's cleaning the grill. I don't know.
Okay. I was like, whoa.
And I didn't even know until you said it. I'm like, oh.
Should we all just wait for Dr. Henry? Because I'm kind of confused.
Well, that's what he was doing with the other group, the calculation. So he should come back and do it with all together now.
Yeah, because all I have is just the average of peaks for me, and then the percent.
That's all we have too.
And we also need to do the acidity with the pH strips.
Yeah.
I don't have the rest of that. I don't know.
Dr. Henry, are you back?
It looks like this, like a little.
No, I have that, but I mean, I don't have the instructions for that.
Yeah, he doesn't say what to do with these things.
It just says add vinegar, 5 milliliters of vinegar, and baking soda.
Oh, dang, I don't have that on mine.
He didn't say anything about vinegar.
It says at the bottom, but he did say that we're going to need vinegar. I just can't remember how or why.
Because we're gonna try test the pH balance, I believe, for vinegar, one for baking soda, and then one for something else. There's 3 of them. I guess your regular solution? Or maybe the cabbage one. I don't remember.
I think he should just cancel this lab since we have a lot of homework.
It seems like he's coming back. But for some oh, there he is. Dr. Henry, I'm glad you're back.
What have you guys done? So you guys completed? You did your 3 times, right?
Yeah, 3 times.
Okay, good. Okay, so you recorded the volume for 3 times. Now I want you to take the average. Take that average.
Yep.
Okay, everybody took the average. Good. Okay, so the other part of the lab is you're actually going to be playing with the pH paper. So I want you to determine the pH of the Kool-Aid, the original solution of Kool-Aid. I want you to determine the pH of vinegar and also baking soda. So what I want you guys to do is take 1/4 of a teaspoon of baking soda, put it in 5 mils of water, and then use that to determine the pH. So use the strips, do the strips first, and then you're also going to make a solution of your cabbage indicator. Now, Kalinga, your cabbage indicator is a piece of crap, so it may not work the way it's supposed to, but still try it anyway.
I thought it looked kind of brown.
Your cabbage indicator, yeah, I think it's actually, I believe
Yep.
it's,
Dr. Henry, did that go over your head?
no, I guess it went over my head.
Because you said, well, our cabbage was a piece of crap, and I said, I thought it looked kind of brown.
I get it.
Yeah. Oh, okay. All right.
You got jokes. You got jokes.
Heather's like
We take
Okay.
the pH of the solution we made in the beginning, the baking soda and vinegar.
Yes. Yep. So you're going to take the pH of baking soda and vinegar.
The 1/4,
Together?
1/4
What was,
baking soda and then
Baking soda and the vinegar together?
no, not together, independent of each other. Yeah. So you're going to take a little bit of vinegar. You're going to put it in a conical tube, and then you're just going to dip your pH meter in there. That's
water
it.
is in it?
And so if you take a look at the lab, it should show, may not show.
Yeah, mine like stops it. Doesn't show any other instructions.
Yeah. Does it show the indicators, the scales and everything?
Yes, it does show that.
Okay.
Are we cutting our strips?
It's really weird because mine don't show anything here.
Mine shows, I mean, I could share.
How much water do you put in baking soda?
5
yeah,
ml.
you can rip your strips or cut your strips.
Sorry, I had to step out. So how are we doing this again?
So mix 1/4 teaspoon of baking soda with 5 ml of water. Test it with your pH strip. And then test the Kool-Aid separate on another pH, and then test the vinegar separate.
What was that?
10 milliliters of water into the baking soda.
No, 5.
5, gotcha.
Okay.
Okay, so get a conical tube, Diana, and put 1/4 teaspoon of baking soda, and then add 5 ml. Yeah, put 5 ml of water. Add baking soda to that. Switch it around a little bit, and then put the pH. And then put the pH strip, and that's okay.
Thanks, Chrissy.
Okay.
Green?
So how much water? 5 ml?
5.
Dr. Henry, can I use apple vinegar, apple cider?
Yes, you can.
Okay,
It should
good.
work exactly the same way.
And how much of the strip do we dip in there?
Just a little bit. You don't need much of it, just a little bit of it.
Dippy dip.
And the baking soda, you said 1/4 teaspoon?
Yep.
1/4 of a teaspoon, yes.
So it turned kind of green.
Okay, so then you want to record the color. And then you want to compare that to the indicators.
For the indicators, Dr. Henry, if we dip it, will it change color after that? Like besides the reaction?
It should be pretty instantaneous, right? Some things act a little slower than others. Typically that's diluted solutions, but it should be pretty instantaneous. So you should get a pretty clear idea of what the pH is.
My Kool-Aid is like red orange. Is that
Okay.
that's fine?
So then what would that be? If you guys take a look, let me share my screen. You guys, let me share my screen. You see my screen now?
No.
There you go.
Yes.
Now it is, yep.
Okay. So you want to calculate the pH, okay? Or determine the pH based upon the color. Okay. So you just said yours was like a reddish orange.
Like a 1, I believe.
Okay.
And mine's like a 4.
And yours is like a 4.
Mm-hmm.
Okay.
For the baking soda?
Yes.
Yeah, my baking soda was a 4.
Baking soda was a 4. That's interesting.
My
Mine
baking
mine looks like a 6 or 7.
yeah, same.
Yeah.
Mine's a 7.
Mine's a 7, yeah.
This is
Yeah.
mine right here. Can you see it, Dr. Henry?
Somewhere.
Do we shake it up? Are we supposed to shake it up?
Mine is like a
Yeah, it should. You want to make sure it's mixed well.
Yeah.
Yeah. So your baking soda, it looks a little funky there.
Mine?
Diana P. Yeah. Yours look, it should be, it's a
I
little
got
light.
the cheap one at the dollar store.
What was that?
I got the
Cheap one.
cheap one at the dollar
The
store.
cheap one at the dollar store. Can I ask you something? Have you
Yeah.
kept it open for a while? And has it been very humid?
It's been in my fridge because I
Oh, mine's been open, yeah.
See, I just opened mine and mine's green.
from
like
last
that.
experience, last experiment, and then I put it in my fridge.
Okay. So when you put it in your fridge, it actually, you're using it to kind of absorb the moisture and everything like that. So what happens in that case? It gets those those hydrogen ions
Uh-huh.
that are coming in from the air and all that stuff. And so it's going to change the pH.
Oh,
Yeah, so the best thing to always do is like, if you want to keep your baking soda kind of good and everything like that, so that it actually bubbles nicely and all that, is you want to put it in a sealed bag.
okay. So my experiment was fine.
Dr. Henry,
Record it and just say, I kept it open in the refrigerator. It's just an experiment. Right?
Okay.
do you see mine, Dr. Henry?
I see yours, yes.
So what color should it be, the baking soda? Because mine's kind of like a 7, 8 as well.
It should be around, no, it should be around an 8.
Oh,
That's the-
great. Okay. Yeah, it's like a, yeah.
Dr. Henry, is 6 acceptable?
For baking soda?
Yeah.
Well, anything's acceptable. The data is what it is. You guys don't understand. You can't fudge your data. It is what it is, right? But you just need to be able to explain why is it more acidic when it should be more basic? And then, like I was telling Diana, if you had your baking soda open a while, right, what happens is that those hydrogen ions are gonna come in and cause it to be a little more acidic because they're gonna start interacting with the baking soda, and then they're gonna come together. So that's
Mine's an 8, right?
That's a hard tell. I don't know. That
Yours
looks,
looks
it
like 7.
looks 8-ish. It looks 8-ish.
It's not that dark. It's not like 7. 7's real dark.
Well, it's not 7. No, it's definitely not 7.
Between a 6 and an 8.
Yeah, but does it have that bluish in there?
Yeah, it's like
Yeah. Okay.
aqua, kind of green.
Yeah, so
Mine's
then
a-
it's probably between the 8 and the 9. So, yep.
My baking soda is a 4.
I'm gonna go with
Your
an 8.
baking soda is a 4.
Yeah.
Okay, was yours baking soda left open? and
Yeah, it
exposed
was.
to the air?
Yeah.
Yeah. And particularly in Kalinga, let me tell you, that air is very acidic. So
What do we do with the
The
cabbage?
vinegar. The vinegar, I got like a 1.
Yeah, me
Okay.
too.
That's fine.
good.
Okay. I was
Dr.
getting.
Henry, how do we know if our Kool-Aid is not just dyeing our pH
That,
like?
that is a very good question. That is a possibility that it is dying. If you have red Kool-Aid, it's a strong possibility that you're that you're dyeing your strip, right? Because if you get Kool-Aid on your hand, doesn't your hands turn red?
Yeah, my hand's all red.
Yeah. So that is a possibility, right?
How much do I
You also
baking-
know, but you also know from what you've done with the baking soda, right? Is that you know that it's an acid, so you know that it should be acidic, right? And so it's going to be hard. Yeah, it's going to be hard to determine. So, but you can only do the best you can do. We have the limitation of the color.
So one was water and baking soda, and the next one is
This vinegar?
vinegar.
Yes.
That's it.
So what happens when you put it in vinegar, Aaron?
It turned kind of orangey.
It turns orangey red.
Yeah, like a number
One.
Okay.
Yeah, like a 1.
Add anything to the vinegar?
And how does that compare to your Kool-Aid?
Mine's like burgundy.
Do you see mine?
Yeah,
You see mine, Dr. Henry?
I don't see yours. I mean,
My Kool-Aid and vinegar strip look identical.
You don't see it?
I'm sorry, I had to
So there's a bunch of people, Heather. He can't. There's like put your high five up on your reaction.
Dr. Henry, I have an annoying question. What do I do with the vinegar again? Because I
You're
had
gonna
to.
put- You're gonna put the strip in the vinegar,
Okay. And then after that.
and then you're gonna read the pH.
I'm gonna put a clapping. Look it. I did a
You also
clap.
clapping? Keep talking. Keep talking. I see you now.
I did a clapping.
Yes, I see it. I see
I did a
it.
clap. Like hello. Okay. Oh, so that's a 1.
Mine looks like a
Yes,
2.
that's the one. Okay, so what was that, Daisy?
Oh, okay. You're going in the dark? Okay.
Ah, that's good. See,
Dr. Henry.
that's good. That looks like it's about a 1-ish.
Dr. Henry.
Yeah.
My vinegar says it's distilled white vinegar. It looks orangey.
Yeah.
Yours
Yes,
is
my vinegar is orangey.
My vinegar was orangey too, Diana.
So light orange, like number 2.
Yeah.
Mine's like a number 1.
Okay, let me ask you this, right? Is it an acid based upon the scale?
Yes.
Yes.
Okay.
As long as it's not like a blue, right?
You're doing good, right? So you know that it's an acid based upon the scale. It's not turning purple, is it?
No.
No.
So that means that it would be a base. So in this case, we know that it's an acid. So you guys are all doing okay. Okay, so the whole purpose of it is we want to be able to sit there and recognize. So acids, we know that acids have the H+ ions, right? So it dissociates into those H+ ions. The more H+ ions you have available, the more acidic your solution is going to be. The less H+ ions that you have available, the more basic your solution. So we know that baking soda, it has technically has 1 H that it can give away. So it can be acidic or it can be basic depending on the situation that it's in. Is it going to be able to give away that H that it has? Right? Normally, so carbonic acid has 2 H's typically, right? And so it gives away 1, but it kind of keeps the other one. And so baking soda is just sodium bicarbonate, which means it's NaHCO3. So you have that 1 H. Technically, that can go either way. So depending on the circumstances, it's going to do certain things. Sometimes it's going to act as a base, and sometimes it's going to try to act as an acid where it wants to give away that that proton. Okay.
So we did 1 vinegar, 1 baking soda. Isn't there a third one?
Kool-Aid.
Kool-Aid. Oh, so the original solution now?
Yeah.
Yes, solution 1. Okay, so you've got your acid and your base, right? So now what you're going to do, you're going to do the exact same thing, testing with your cabbage indicator. So what you want to do with your cabbage indicator, you want to put your water or your conical tube, your 15 mil conical tube, put water up to 14 mils. And then you're going to add all your cabbage indicator into that tube and you're going to mix it. Okay. And then you're going to put 2 mils in your Kool-Aid, you're going to put 2 mils in your vinegar, and you're going to put 2 mils in your
Dr. Henry, it sounds like you're underwater.
Yeah. What'd you say? Yeah.
sorry, let me get a little
We
closer.
can't hear you.
I'm running away from you guys.
What was the Kool-Aid supposed to look like?
So what you're gonna do is, with the cabbage indicator, you're gonna put that in 14 mils of water. So you're gonna put 14 mils in a conical tube, and then you're gonna dump in your cabbage indicator, and you're gonna mix it really well.
Distilled water?
Yes, the distilled water that was given to you guys.
Dr. Henry,
Pour out 14.
Yeah.
do you see me? Do I need to do a clapping?
Hold on.
My Kool-Aid is just this red. It looks like 0.
Okay.
Is it supposed to?
Is it an acid?
No, it's not.
What are you guys determining? What is the main ingredient in
Yeah,
Kool-Aid?
acetic acid. So
You mean
yeah,
citric acid.
citric acid, yeah.
Yeah. So yeah, you would assume that it's going to be very acidic, especially since it's concentrated. It's going to be even more acidic, right?
Okay, so it's good then.
Yep.
What is this cabbage stuff?
Acetic acid. What's
What
acetic
are we
acid?
what are we doing after we find the pHs of all our solutions? Are we just waiting?
You're waiting so we can do calculations.
Okay, perfect.
Dr. Henry, can you repeat that? Sorry, I was cleaning. Can you repeat the one with the cabbage?
14 mils of water in your 15 mil conical tube.
40? 40?
14.
Oh, 14.
Yeah.
Dr. Henry, it's the ones that you provided, right? These?
Yep.
Good,
the
I
distilled water.
almost threw them out. Last lab.
14 mils of water, and then you're going to put in your cabbage indicator.
All of it, right?
Yep.
For the 14 mils, are we using the water that you gave us?
Yeah.
And then all the cabbage indicator.
Yep.
And then shake it up.
And then drink it?
Mix it well, shake it, and then you're going to dump 2 mils in your Kool-Aid, and you're going to dump 2 mils in your vinegar, and you're going to dump 2 mils in your baking soda.
So my Kool-Aid is still in this thing. Can we drop it in there, or do you want us to do 5 mils?
You can drop it directly in your
Okay.
yes.
Sorry, I was gone. Where do you want us to pour that mixture of the water and the cabbage?
In 2 mils in your Kool-Aid, 2 mils in your vinegar, and 2 mils in your baking soda.
So 14 ml of water.
Dr. Henry,
Yes.
how much are we supposed to put in vinegar?
2 mils. 2 mils.
2 mils? And that's
Yep.
just gonna be in a different like little
Oh,
Two?
how much vinegar are you supposed to put in? You can use 5 mils of vinegar. Just 5 mils, so you're consistent about everything.
Dr. Henry, do I put all of the red cabbage powder in the 14 milliliter of water or no?
Yep.
Yes.
Stinks.
And you said the vinegar is supposed to be in the 5 milliliters, correct?
Yeah.
Okay.
Like kimchi or something, fermented
My
cabbage.
red Kool-Aid looks like red Kool-Aid.
You said it looks what?
Darker.
It looks darker red.
Oh,
Darker red.
stinks so
So
bad.
if you look on the screen, these are the indicators for your cabbage. This is what they should look like. This is how I know that they Amazon gypped me out of my cabbage powder.
Is it actually made out of cabbage?
What was that?
Is it actually made out of cabbage?
Yep.
So
Oh,
14
that-
ml with all of the cabbage in it, and then shake it up.
Yes.
And then what else?
Can somebody tell her?
Yeah, somebody.
2 ml in each one. In each,
I can't hear you, Michael. You
2
sound
mls in
drowning.
your vinegar, 2 mls
2
in your baking soda, 2 mls in your Kool-Aid.
2
of
ml
cabbage.
of baking soda, vinegar, and Kool-Aid.
Of the cabbage.
In the cabbage?
No, cabbage goes into the solutions.
You're using the
think I
indicator
fucked it
to
up.
determine the pH of, so you're gonna put 2 mils in each of your tubes. You're gonna put 2 mils in your baking soda, then you're gonna put 2 mils in your vinegar, and then you're gonna put 2 mils in your Kool-Aid. Okay, this is your baking soda. 1 baking soda.
2 milliliter of cabbage in each of those?
Yes, and each one independently. Yes. You're gonna put 2
Oh
mils
my
here.
gosh, I messed it all up and I threw it all in one. Cause somebody said you put it all in one Chronicle tube and I threw it in one.
Yeah, you put all of your cabbage into
The water.
14 mils of water.
Yeah.
Is that 14 mils of water?
Yeah.
Okay, so then you're good. So you're taking 2 mils from there and you're
Oh.
putting it into your baking soda. And then you're gonna take 2
Okay.
mils. This is your cabbage solution.
Okay. All right. Whew. Scared me.
I can spell.
Okay, so I'm running out of conical tubes. Hold on. I'm gonna wash this out. What do we do with this distilled water?
It's good now.
This
You've
one
already
is
used it for
big
what
one.
you need it for. You're good to go. You only needed it for the cabbage.
And
I'm
now
not gonna lie to you. I use bottled water.
It's okay. That's fine.
and now we measure the pH of all of the mixtures.
Yes. So you measure. So you add the cabbage juice to each one, and then you compare that to the scale up here.
So you compare for each one, right?
For each one, yes.
Okay, so this one. it
Hold
looks-
on.
Are we adding 2 milliliters of cabbage to the whole bottle of the solution?
Okay. You're adding 2 mils. So the best thing to do is get 5 mils of everything so it's consistent. But you can just add it directly to the Kool-Aid because all you want to do is get an idea of your pH of your Kool-Aid.
How much of Kool-Aid do we need?
What was that?
How much Kool-Aid do we need in the 2 mLs of the cabbage?
You put in 5.
You already have.
Put in 5.
Okay.
Dr. Henry, what if we don't have enough of these little pH strips?
You should have enough pH strips.
I
You can
only
split
have
it in
4.
half. You don't have to use the whole thing for one. And you're only taking 3 pHs, right?
Yeah, but okay. I used half of one strip. Hold on.
Okay.
So how much baking soda goes in each one?
The same amount that we put into our thing initially. How much was that?
1/4. All right.
Okay.
So 1/4. And water? Any water in there or just baking soda? Just baking
Water.
soda. Water? How much water?
1/4 in water because you want it to be in a solution. It makes it easier.
So how much water are you guys putting in? 5?
And this
5,
one.
10, 15, 20, 21.
Co-association with cap. Is that gonna be like a 2?
I don't know. 1/4.
It's gonna be like a 1. The fuck is this?
Oh, is the baking soda like? Is it okay if it's blue? Because my baking soda.
Yeah, it turns blue.
You said, is it okay if what?
It's blue.
Your bake. It's okay if it's blue. Yes, that's exactly where it's supposed to be.
My vinegar
Mine-
was blue.
Mine are all purple.
Yours are all purple.
Yeah.
Yeah. So we had the bad batch of red cabbage extract. I actually think they gave us powder. So Kalinga, you guys got screwed. I got screwed. So you guys got screwed.
So
Man, they got us.
Yeah.
how much vinegar are we putting in again? 5?
We're using 5 mils of everything.
Of everything. Okay.
Yes. Yes.
Is that good?
Christy, you have your hand raised.
Yeah, I can't tell if that's 0 or just like that's the Kool-Aid. I just kind of stained it. Because I have purple Kool-Aid.
Okay.
Looks brown.
red.
What'd you say?
Yeah, that's red. That's gonna be
Okay,
like
if all mine kind of look greenish.
Thank you.
is between like a 0 and a 1.
A 9. This one was like a 9, so that one was my.
Can you go over there? I can't hear you. What'd you say? I'm sorry.
I said it's a 0 or a 1. It's between
Okay.
0 and 1.
Okay.
So, Dr. Henry, after we put 2 ml of this purple beet juice in the baking soda and then also in the vinegar, we're gonna use test strips.
No, you should have already used your test strips. You can do your test strips first.
Okay, that's what I was clarifying before I put the beet juice in. All right.
Yeah, you can do it the other way around. It'll work out the same way. You should end up with the same results. Only thing, your test strips are going to give you different results. You're going to have different colors than the.
Oh,
because
no, we already did test strips. So remember earlier, all of us? Okay, so now we're on to beet.
I know, but I tell you guys these things. Never mind. Go ahead.
So now we're on to beet juice. So we're gonna put that in 2 ml and then we just want to see what color it turns.
That is correct. Yes.
Nice. Cool.
The baking soda is blue.
The baking soda is blue. That's cool.
Okay. So I'm sorry that you guys got screwed with the Kalinga. Kalinga got I got screwed, so you guys got screwed with the beet juice.
We're not from Kalinga. We're from
The
Hartnell.
thing is, if you put in bleach, right, it'll actually, if you put in a strong base like bleach, it'll actually turn grayish, like a grayish blue color.
So Hartnell got screwed too.
No, Harnell's, yours are good.
That's good.
Your beet juice is good.
All mine are looking like blue green.
All of yours are looking blue-green?
Yeah.
Okay, that's weird.
Well, my first one with the vinegar, it was like a 10, like a green. And then the Kool-Aid one was kind of like a 9.
Uh-huh.
The baking soda was like an 8.
Well, your vinegar should have been about a 3 or a 4, 2, 3, or 4.
Let me try it again. Hold on.
What color is this supposed to be? It's not even on there. This is vinegar.
Yeah.
Dr. Henry, I think the dye in my Kool-Aid is like super strong because it barely changed any color when I added it.
Okay. So again, Kalinga, yours is screwed up. Your colors are all, so I believe it's beet juice or beet powder. And so you have 2 extremes. You have red, or you have purple, you have pink, and you have blue. That's your option. But they have to be very far from each other in terms of the pHs.
What color would you call this?
I'm gonna say that's kind of like that purplish, pink,
Pink.
reddish purple. Yeah.
Red, purple.
So
I mean, are we making an indicator like that little bottle one? So if I would pick 4
Purple.
on your.
so normally that's what you would do, right? So you use this because this is your indicator. This tells you where the pH is at, right? If it's below 7, it's acid. Above 7, the base.
Okay, so
And
I'll
based
choose
on the color.
Give me that little test strip.
4.
But in Kalinga, you guys are Kalinga. So if you're at the Kalinga campus, if you're a Kalinga student, or if you registered for CHEM-002A, your beet juice, your quote cabbage juice.
Yeah,
does not
that's mine.
work.
Yeah, mine's out of 4, so that's not good then, right?
Yeah, that means that it's something wrong with your cabbage juice. It's not your solution.
Right.
Cabbage juice.
Good. Thanks for clarifying that for the bazillionth time for me.
Okay. So again, and it's kind of like, yeah, like a 1.
It's like a 1. Okay.
Yeah.
Good.
Dr. Henry, I kind of have some annoying news.
What is your annoying news?
I kind of blinked for a minute and now I'm kind of lost. I just finished the water baking soda. Now I don't know what to do with the cabbage powder.
Heather, can you tell him what he needs to do?
Yeah, where are you at? From the beginning, Allie?
Let me go. I'm gonna go check on the other students that are doing calculations.
How come, is your name Allie? A-L-I?
No, it's Sal. I was trolling a Zoom class and I
Are
put the
we-
name Ali G.
Yeah.
Are we good now, Dr. Henry?
Like you're like Aladdin or
Yes,
something.
all you have to do now is calculations. If you're comfortable with the calculations, you can do it on your own. If you're not comfortable with the calculation, then I will be there to help you.
Dr. Henry?
Coming back to this for calculations?
Yes, I'm gonna come back here in a minute. Yes.
Okay, wait, I'll wait.
Dr. Henry, this is Catherine. Everyone from that breakout room left.
Okay. So, actually, they're still there. You're the only one that left, but I'll be there. I'm going there right now, so.
Okay, who was it? Heather, were you gonna help me?
Oh,
Let's do
yeah.
this.
Okay. Just let me clarify one thing, then I'll be there. I'll be there. Okay. This is baking soda. It's like a very dark violet. Well, there went the screen. So would you have said that was whatever the opposite of that was? 5, I think it was. Where'd he go? He left? He abandoned us?
Yeah, he left the other.
What
breakout.
are you guys, what did you guys have for baking soda?
Like
I got
this,
like a light,
bluish
I got
purple.
like a dark.
Anybody have violet?
I got like a blue, purple. That's really more blue. It was more blue than purple.
What number did you guys pick for that?
I got an 8.
11.
Yeah, I put 11 too.
What'd you guys get for your
All right, where's
vinegar?
Sal at?
I'm here.
Oh, for the
All right, Sal. Where are you at, Sal, in your experiment?
So I just finished testing the acidity of the baking soda and water. I know we have to throw in the cabbage
Kool-Aid.
powder.
Did you do your Kool-Aid one?
No.
Do the
See, that's
acidity
where-
level of your Kool-Aid, your solution 1, your first one. Yeah,
This one.
yeah, yeah. So put some of that in your 15 ml.
All this stuff is making me want to drink like juice and Kool-Aid.
Ew, you wanted the 50 ml in here?
Yeah, you could just put some in there. You're just gonna test some of it. It doesn't really matter how much.
There's
Wait, you
already
need
5 milliliters of water in here. Is that
No,
fine?
you-
Oh no, it just needs to be by itself. The solution.
wait, I thought he was doing the cabbage thing.
He's not doing the cabbage one yet. He's still back at the beginning.
Oh,
He only did the baking soda and the
She
vinegar
already
one.
got the solution of the thing.
Yeah.
It's fine. All right, I'm chilling. Let me
Yeah.
take a picture of that so I can read it.
Yeah, I thought your name was Sal, but it threw me off when I seen Ali G on there. I was like, okay, Ali.
I was trying to throw a Zoom class and I like putting that nickname because it's funny. You guys ever seen the show Ali G?
No.
It's stupid. Don't watch it.
Is that the guy on the picture that you put?
Yeah.
I was like, that guy does not even look like you.
Okay, I have
I have
a
to take it down.
um
Anyway, 5 milliliters of water, cabbage powder.
Okay, so you got all 3 test strips done, right?
Yes.
Okay, so now you got the 5 ml of the actually it was 14 ml. 14 ml of the water, distilled water.
Yep, I have it right here.
It should be the one that came in your big 50 particle tube. So put 14 ml in of water in this, and then you're gonna dump the whole little tube into that of cabbage beet juice.
So 14 ml of the deionized water in the big one.
No. Keep it in the little one.
Keep it in the little one,
Like,
but you
it's
want
clean.
Yeah, but you can't. That one doesn't have 14, does it?
yeah, he just has to really read it. Well, I mean, it's not accurate because it's gonna it's at the 0.5 mark, but it's because
then-
it's because the water what do you call it with a D?
Deionized, the
Yeah.
special water.
Yeah, special water came in the bigger tube. So anyway, we transferred it to the smaller 15 ml. So we'd have 14 ml. So then when you put in the beet product out of this little capsule, it'd make 15 ml exactly into this tube.
Mine came with a little one. Oh well. It's gonna
It
be a
doesn't
pain
really
in the-
matter. Yeah, so just make sure you have 15 altogether. That's with the deionized water and with the beet juice powder.
All right, so dump the whole beet juice powder in there.
Yeah, and then shake it all up. And put the lime in the coconut and shake it all up.
All right, all shaken up. Now what?
Okay, so after that, you just do a little magic spell over.
You started cracking up. You're like,
She's laughing so hard she can't breathe anymore.
abracadabra.
The sound is over.
Color.
Oh my God, I love school. Okay, so now what you do is you're gonna oh shit, what do you do next? You're gonna get the color.
You get 2 ml.
2 ml. Yeah.
I get 2 ml of the cabbage water.
And you're gonna put it inside of new vials now. So you're gonna have one with baking soda water, and then you're gonna have another one with vinegar.
Dr. Henry. Hello.
On mute. Incognito.
Yes,
Oh.
hear me now.
So the vinegars should be alkaline colors. The conical tube one should be
No,
neutral.
vinegar, no, remember, vinegar is an acid. Vinegar is actually acetic acid. So it should be which colors?
0, 1, 2, or 3,
Yeah, somewhere in that range.
4, 5, or whatever.
Yeah. All the way up to pH 7. All right.
Okay. Okay.
Al, where you at now?
Hold on, wait a minute. Okay, yes, so vinegar should be like the blue greens, like number 7. And
Oh,
then the
shit.
conical tube, like orange yellows. And then what about Kool-Aid mix, like the red?
Yes.
Red orange?
Yep.
Okay.
Yep.
Okay.
Are you talking about the pH strips or are you talking about the cabbage juice?
No, the pH strips.
Okay, good.
Yeah.
Okay.
Hey, Dr. Henry, my Wi-Fi clocked out. I was
Okay.
asking what the cabbage was. If
A vegetable. It's a vegetable.
Oh my God, Heather.
The cabbage is this one. It's the little powder that comes in the little tube that you got in your bag. Do you see it? The cabbage, the little tube with the red powder?
Yeah, I already mixed everything. So, and you said
Okay.
Kalinga's was bad.
Yeah, yours is bad. Kalinga's is bad.
So what would we put down for the
So
cabbage?
for- in that case, you would just say that the cabbage indicator is probably not cabbage indicator. It is probably beet juice or beet. Beet powder, beet extract.
What does beet powder do?
For
Okay.
sure.
Okay. So are you guys good? Everybody's caught up?
Nope,
Oh,
waiting
God,
on
no.
Sal. Sal's almost there.
So what
No, I
color
got
are
it.
you getting?
So 5 ml of water with, yeah, something
Baking
happened, but
soda?
don't worry about it.
Baking soda? No man behind.
I'm down bad. Baking soda, water, and we add how much of the cabbage water?
2 mLs.
Yeah, in each vial.
That's gonna be so hard to get it right.
Well, you just subtract 2 ml from your 1 each time you pour something out.
I used my dropper.
I was wondering, you know what? You're so smart, Christy. I seen these here a long time ago, and I wondered when we were going to use them.
Dr. Henry needs a drink.
Today. It's been a long day. Unfortunately, it's been quite like this the entire day. I sat in a meeting that technically was supposed to be 30 minutes for 4 hours. It was painful.
Can I just ask when we were going to use this straw, though? Was this for baking soda too?
It was actually used, it was supposed to help you get your baking soda and things out. You
Oh,
know,
it was for baking soda, the
it's-
powder. Okay. Well,
Oh, I was
Okay.
thinking more like Breaking Bad.
Okay, so now for the vinegar, just 2
so
ml.
We're not gonna get a chance to use the Epsom salt, so I recommend that you guys, after tonight, put a hot bath and pour.
oh yeah.
Yes, pour in your
I'm not
Epsom
fast
salt,
about that.
you know. Yeah,
With alcohol.
yes,
Get some wine and candles or something.
oh yeah.
Hey guys, I think I missed one. So I did the 5 mLs of water with the 2 mLs of the cabbage. That was one, right?
Yeah.
No, 5 ml of what? Oh, you got to do baking soda in the water.
Kool-Aid solution.
You do the same with the vinegar?
Vinegar without baking soda and water. Yeah.
So 2 mLs of the special cool water with the vinegar.
So for heart now, Dr. Henry, they all have to be blue, right? Because this one's blue
No.
too.
Nope, it shouldn't be blue. It depends on what you have.
No, the vinegar one was like a 1, like a reddish color.
Yeah.
No, my vinegar was this.
Yes, my vinegar was 1.
It was just vinegar and the cabbage?
Yeah.
Yeah.
Yeah, that looks dark, like a red. No.
No, it's blue.
Oh.
Dr. Henry, so for Kalingas, we all just, for the cabbage, we just put like the cabbage
Yeah, it was defective, yeah. Just all you
Okay.
need is put it as being defective. Yeah, I'm sorry, next time I'll test the product before I push it out.
You know what, Dr. Henry?
Unacceptable.
For everyone.
What was that?
Just unacceptable.
What about for everyone?
It's been a long day for all of us.
Oh, I know. I know. It has been a long day for all of us.
I have a mess. My boss in the morning is gonna come, like, have Roxanne, and I have me and Aaliyah. I have to clean my office, so I have to clean up at the end.
Yeah, it has been a lot. Your day is longer then. Yeah.
My day, yes.
Yeah.
Especially having the bosses every day here in my office drives me crazy. Because we're starting the harvesting for the grapes and the cherries, so.
Ah. Oh, grapes and cherries. So you have cherries?
Yes.
Ah, so you can give me some cherries so I can make some cherry wine?
Yes.
Oh, I love you already.
They just brought us like boxes of cherries.
Oh, really?
Yes.
Ah.
And then after that, it's we're gonna prepare for the harvest for the pistachio and the almonds.
Oh, nice.
Yeah.
I want some pistachios. I want to see about making a pistachio liqueur. Okay.
Perfect.
Where are you from again? We want the liquor.
Kayla, are you there?
Yeah, I was just gonna ask, is Cole or anyone else gonna be available still? Because I'm having trouble a little bit with the homework.
For tonight?
No, just like
In general?
yeah, just in general.
Oh
for the-
yeah. Oh yeah. So just hit up their office hours. I'll talk to them about posting office hours for reviews for the exam and all that stuff. So I'll talk to them and I'll have them send you emails.
Dr.
regarding-
Henry, you want grapes so you can make the wine too?
Oh yes.
Okay, we have grapes too.
Okay.
We
Perfect.
deal with all the like the agriculture thing, which is like all the fruit, vegetables, and everything.
Okay. Yes, I gladly will take grapes and cherries and pistachios.
No, I'm serious.
I know, I'm serious.
I can get a box, and then we were doing the blueberry as well.
Oh yeah, if you can give me some blueberries, hell yeah. I love
Okay.
blueberry wine.
I'll get you some boxes.
Okay.
I'm gonna email
so
you
like-
my address, Dr. Henry, and then once you're done doing the liqueur, you can mail me like a little baggie, okay?
Oh, okay. Is that what you're saying? So I currently have a pear beer, just some pear wine. I
Pear-
have
Is
pear,
it
yeah.
barefoot?
What was that?
Is it barefoot pear wine?
Barefoot pear wine? No, it's Dr. Henry's pear wine.
Oh.
Yeah, so I have nectarines. I have nectarine hibiscus. I have strawberry hibiscus. They're all fermenting. I need to clean them up.
Are you
That
gonna
was
drink
supposed to
them
be
all
done.
after this lesson?
Do I need some help cleaning them up? I always need help. Do I need help drinking them? Probably.
We could all help you.
Oh,
We'll drive up to Kalinga.
Yep. Or Hanford or wherever you're.
The party after chemistry classes.
after you guys all pass my class, right?
Oh my goodness.
And even if I don't, I'm gonna need some to cry with it.
I'm not 21, but can I?
I forgot there's babies in here. Aw.
Okay. Okay, you guys ready for calculations now? Sal, are you with us?
So far, I'm hanging.
Well, sorry. Hello. It's me again.
Step one.
Kool-Aid. Kool-Aid, right? We have to do one with Kool-Aid with the beet juice, right? 3 of them?
Yeah.
Okay.
You
Sal,
don't
are
have
you
to
with
all
us?
three- you don't have to
That's
do it 3 times. You have to do it only once. So I will also try to do a makeup lecture for you guys. I'll send you, I have to figure out when I can squeeze you guys in. I'll send you guys a time for it next week. Or this weekend, probably. So if you're available, show up. If not, watch the video. So. Okay.
Wait, what was that? Can you repeat it? Sorry.
A makeup lecture. So, because I'm feeling guilty about not being able to give you guys the lecture on Tuesday since my power went out and everything. So
Don't
I'm gonna
feel
try to set
guilty.
up a time for a makeup lecture this weekend.
Don't feel guilty. That was out of your control.
Yeah, I still don't know why the reason why the power went out. So
You can give us
All
a
day?
credit. That's okay.
it wasn't all day. It was for about 3 hours,
Oh,
2 hours, something like that. So right after, after your class ended,
it decided to.
it decided, well, we'll maybe come back on, and then it flickered for a bit, and then it went back off. And
One
then,
of the students in the class.
yeah, they're like,
Yeah,
those lines. Yeah.
maybe he'll forget about the lab.
That's funny what Michael put.
That's why I always ask for cash. Yep. Okay. Let's see. Okay, so let's see if we can get those calculations going. Sal's almost to the finish line, right?
Yep, just got the last one.
Perfect. Okay. So I'm going to share my screen.
Real quick, so that's it for labs, right? We can toss all of our stuff out.
Yes, you guys are good. Yes.
Thank the heavens.
Oh my god, I almost spilled the cabbage powder.
Did you say you almost drank the cabbage powder?
No, I almost spilled it. That would have been a disaster. It would have smelled in here.
We can throw away the cabbage, the little little with the cabbage indicator in the garbage, right?
You can put it in the garbage or you can put it in down your sink.
Wait,
It's
so once
cabbage.
we find the pH with the strips and then with the cabbage, if it wasn't broken,
Yeah.
we can start cleaning.
Yes, you can start cleaning and disposing of everything. But don't start yet till I give you the calculation so I can give you the key to the city, Okay, so at the end of the day, there are a few calculations that I want from you, okay? At this point, you should already been able to calculate the mass, the percent mass. This is percent mass. This is how you calculate percent mass. So we've always calculated percent mass. It's the mass over the part over the mass of the whole. So in this case, the whole is going to be the Kool-Aid and the water. So we're gonna.
So we did 2.5 over 100 and then
That's
times
right.
100? Okay,
That is correct.
good job, Christy.
So write that on the board right there.
I was your substitute for a little bit.
Good. Good
Came in
job.
clutch.
Very proud, very proud. Now, if you guys look at this chemical equation, it's balanced, right? Yes?
Yep.
Okay. So since this guy's a 1-to-1 ratio, for every 1 mole of carbon dioxide we have 1 mole of citric acid. Okay. So we know that there's a 1-to-1 ratio. So by us calculating, since we know that carbon dioxide was the gas, that was the gas that caused the volume. And so we were able to calculate the volume of gas that was being generated. What did you guys get for your volumes of gas? Give me some answers, please. Are you with me?
Is it the 45?
You got 45?
With 46.
You said 45 or 46, right? And that's
Yeah.
milliliters. Is that correct?
Yes.
Okay. Now we want to change our milliliters to liters. How do I do that?
Times
1,000.
1,000, yeah.
Is it times 1,000 or divided by 1,000?
Divided by.
Okay. So if we divide this guy by 1,000, okay, so that's going to cancel out. So we're going to get
0.045.
Dr. Henry, say in the lab, you want us to mention if we use like, say, because for some of us, a Kool-Aid was too strong, so we use like 5 ml of Kool-Aid and then 5 ml of water. Do we mention that in the?
yes, you are going to mention that you have to use a second solution. Yes.
So right now we're doing the volume of like our average, right? So you did B
Yep.
and then, right?
So if I got 50, I'm going to use 50, right?
Right.
Yeah. If you got 50 all 3 times, it's 50.
Yeah.
That's correct. Okay. Okay. So then that would give you your volume, right? So the way that we would calculate our number of moles, if we go down to the end of the page, now we're ahead of the game. If it lets me. Okay, you see that box? In that box, we have V in our volume, is equal to Kn. N represents the number of moles, K represents a constant. This is the constant for K.
Wait, Dr. Henry, can you open up your white screen a little bit further? Because I can't see what you have on the right.
My white screen.
Yeah, your desktop, the blue one, it's showing. Could you just like open up your whole, did you write right there? Like 45 ml over 1000 ml? What's on the right of that?
Oh, that's just
Maximize your window.
oh, that's 1 liter. Yes.
Oh, you multiplied it by 1 liter?
Yeah, well, because it's
Okay.
So the K is 24.5?
Yep.
Dr. Henry?
Yep.
So since I got 30, like this is gonna be repetitive like always, but I got 35, 35, and 38, and I divided it by 3, so I got 82.6, and if I rounded to 83, I would divide that by the 1,000
Okay,
milliliters.
wait. So you added them together and you divided it by 3 and you got 82?
Yeah, 82.6, but I was gonna round it to
Okay, now I want you to listen to what you just told me. So you said that you added all these together. You said you got 35. You have 32 And you said you had 30, what was
No,
that?
35, 35, and 38.
35, 35, and 38,
Yes.
okay? Now, anytime that you're doing an average, you should get a number that should be somewhere between these numbers, right? So it should be between 35 and 38. If you have something like 80, that's not correct. So I want you to add these again and then divide it all by 3. So what you probably did was you probably added these two and divided this last one by 3. You know, so you need to put a parentheses when you're doing it in your calculator.
Okay, so.
Dr. Henry, what's in? Oh, number of moles?
N is the number of moles.
So if she adds all those, there should be divided by 3, it should be 36.
Yeah.
Thank you.
Okay. So
You're
then your V that you're going to be starting off with is 36. And so you want it in liters, and that's in milliliters. So you want to divide that by 1,000. So
she should have 0.036.
okay, so now you guys are able to solve for your N, right?
Yes.
Okay. So what kind of values are you guys getting for your N?
I got a really big decimal.
Okay. So like 0.0005.
0.00109388.
0.001.
109388.
Okay, so let's just, for kicks and giggles and make our life a little bit easier, we're gonna make 3 sig figs. Okay, so then you have 0.01909. Okay, so that's the number of moles. So that's good. That should be about, let's see, if I did mine. So mine is, and what was your volume?
My average volume was 0.0268 liters. Because in milliliters, it was 26.8.
Okay. So you got point, okay, so, and you divided that by, I think you're off by a factor of 10, so it should be 0.001, is that right?
Yeah, my average was 45 and I got 0.0018.
Oh,
Yeah.
yeah, I said 0.001.
Okay, sorry. Okay, so that sounds good. Okay, so then that gives you your number of moles, right?
Yeah.
Okay.
You got this by just getting the average, right? And then dividing it by 3.
We're getting the average, and then we plug it into this equation down here, right? Because B represents
Let's plug it in.
volume.
Let's plug it in.
Heather, I got it. B represents volume. K is a constant, and that's the value of that constant. N is the number of moles. So we want to calculate the number of moles. Okay, so then that gives me the number of moles. Okay, here I want you guys to calculate the molarity. Molarity is the number of moles. Wait, there's one other thing before we get to that. So we know that 98% of the Kool-Aid is citric acid and 2% is ascorbic acid. And this is molar percent, it's percent moles. So the majority of it is citric acid. So if my total moles is 0.00109, then how much of that is going to be citric acid, which is what I want?
98%. So
98% of that, right?
yeah.
Okay. So if you have 0.00109 times 0.98, you end up with 0.00106, or sorry, 107. And then that's moles of citric acid.
Okay.
Okay.
Yeah.
Okay, so now we want to use this to calculate our molarity. Molarity is, it's a form of concentration. So concentration is a way of having particles in solution. So things that are typically in solution, it has concentration. And the way that we define our concentration, it's usually going to be solute over solution, right? So like when we talked about mass percent was solute, meaning the solute being the citric acid, and then the solution, or in that case, the Kool-Aid, and then the solution being the water and the Kool-Aid, okay? So here we want just the citric acid. We want the molarity of the citric acid. So we're going to put moles over liters. So this is how many moles that we have in the volume that you guys actually did. So for instance, did you use a dilution for your number? Was this your second solution? Was it the second solution, or was it the main solution?
That was the average of the three.
Okay, but the average of the three. So was it solution one, or was it solution one that had been diluted?
Yeah, it was solution one.
It was solution one. Okay. Okay. So, and how many mils of it did we use?
Of the Kool-Aid or the water?
Of the Kool-Aid.
10.
You used 10 mils of the Kool-Aid. Okay. So we have 10 mils of the Kool-Aid. Okay. We know that. Are you there?
Yeah, isn't it 2.5 that we used, or am I?
Of Kool-Aid? No, that is of the solution. We're talking about of the solution of Kool-Aid. How many mils did you put in the tube? Okay.
Oh, okay.
Okay, so we use 10 mils, right? So we're saying that when you did that calculation, we did it in 10 mils, right? To get the concentration, we wanted moles over liters. So I want to change these mils into milliliter. I mean, these milliliters into liters. So if I change this into liters, so it's going to be, yep, it's going to be 0.010 liters. So molarity is equal to moles over liters. So then we have our moles here, 0.00107 moles of citric acid over liters of solution. So that was 0.010 liters of our solution. And that's going to be our molarity.
Dr. Henry.
Yep.
So for my N, I got 0.46, which I rounded it to 0.0015. And after that, I would divide it by the 98%.
You'd multiply it by 0.98.
Okay.
Because you're looking at the percent. 2% of it is going to be ascorbic acid, and the rest of it is going to be citric acid. So the majority of it is citric acid.
What's the unit for molarity?
It's molarity is just a capital M, and usually we put a line underneath it. Oops. So, or you can just call it moles over liters.
Dr. Henry, how did you get the N again?
This equation down here.
So in that case, we would just divide V by K, right?
That's right. So we just divide V by K because you're calculating, you were able to calculate V, right?
Yeah.
That's the gas that you guys generated.
So that would be like our 0.035, for instance.
That would be your, yes, your 0.05, yeah. Or 0.0, yeah. Sorry. Did you get that, Michael? The thing about about N?
Can we round off, like for my end, I got 0.0199. Can I just round it off to 0.002 or no?
Yes, you can.
Okay.
Let's see, I'm seeing messages here. Okay, Veronica, did you get in? And Michael, did you get in?
Yeah, I got it now. It just,
Okay.
for mine, it would be 0.001428. So for like sig figs, it'll be 0.00.
Use 3 sig figs.
So 0.00143.
Okay, sounds good. Okay, so we have our number of moles, right? Everybody got number of moles?
Yes.
Okay. Let's see. Okay, and you're able to calculate molarity.
Yeah.
I'm stuck with that one.
So I got for my molarity solution, I got 0.2. Does that sound pretty accurate?
Yeah, because you're just going to be moving, say 1, 2. So then it's 1, 2. So it'll be 0.2. Yeah, that sounds good. So in my case, this guy is going to be 0.107. Okay, so that's going to be my molarity.
Okay.
Okay, so again, it's just moles over liters. We know that we added 10 milliliters of our solution. That's the total amount of solution that we added. So we know that this is the number of moles of citric acid that we have.
Even
Okay.
if it was,
What was that?
even if it was
Yeah, even if it was dilute, this will be the concentration of the solution that you have.
with the
Okay.
10, the point, okay.
Yeah, it would be that total 10, right? Okay. Hold
Sorry.
on. Okay. Now go ahead, Aaron.
So the 0.107 is the answer to.
It's for my particular case, my whatever.
Yeah.
Yeah, my N value. Yes. 0.107 would be molarity would be my answer of the concentration that I used to get my values. Okay. Now, if you did a dilution of the original, then what you need to do is you need to calculate the dilution that you did. And the way that you would do that is this here represents the concentration. So we'll use another equation called C1V1 equals C2V2. Okay, C1V1, C stands for concentration, V stands for volume, C2V2, C stands for concentration, V stands for volume. So our C1 in this case would be our concentration here. So it'll be 0.107 molar. It's the volume, the total volume that we had, which was 10 milliliters. We could use 10 milliliters, or we could use that 0.010 mils. So let's go ahead and use that 0.010 liters. I believe, let's assume that you guys did, this is only if you had to do the dilution. If you didn't have to do the dilution, this would be your answer. If you had to do the dilution, then what you're going to do is you're going to say you're calculating C2, right? How much of your original solution 1, did you put in the tube before you did your dilution to 10 milliliters?
By that, do you mean if we put like 5 ml of Kool-Aid and 5
That's correct. So you put 5 ml and 5 ml of water, right?
Yeah.
So that 5 ml will be what you put in of your original solution. Is that right?
Yeah.
Okay. So now you want to solve for C2. So if it's 5 ml, we have to change it to liters since we're using liters over here. So then you'd go 0.005 liters, right? So I'm going to put that in here to keep my unit straight. 0.0. And I'm running out of room. Come on. Okay, so then you want to solve for C2. So if you have 0.005, you bring that over here. Oops.
Are we dividing?
Yep, we're dividing. So you're going to get C2 equals, in this case, this would be 2 times if you look at the numbers. So then that would be 0.214 molar. So this would be the concentration of your original solution.
Oh, okay.
So you multiplied, for your instance, you multiply the 0.107 times the 0.010 liters?
So yeah, so it's 0.107 times 0.010 divided by 0.005.
Okay, thank you. And it's like the cones. I'm sorry, what does that say? The
Concentration?
concentration, yeah, sorry.
For like for mine, it would be 0.2 times 0.010 over 0.005, right, Dr. Henry?
That's correct.
Okay.
Yep, that's only if you had to dilute it to get into that right range. If you didn't have to dilute it, then you just use the original one that you had.
Okay. And then after you have equals C2, and then
Yeah, it just says that's just the concentration of solution 1.
no, right next to, you know how you have your and then equals C2 and then has 0.005 liters, and we're going to divide that again by the same number? Or that's just my answer?
No, this is just your answer.
Dr. Henry?
That's in the box.
No, the top part from the box.
This part here?
Yeah, that's the last part from the top. That,
This
okay,
part
next
here.
part. That part. Up, 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 up.
Right here?
That part. Yeah.
Yeah. So I was just getting it, so I got C2 by itself.
That's if it's concentrated.
Right.
Yes.
Okay.
That's
Don't
if
worry
I
about
had to
it.
dilute it initially. Yeah,
If we didn't have to dilute it, we don't have to worry about that.
that's right. If you didn't have to dilute it, you just stop
Okay.
here.
Let me
Yeah.
do it. 0.2.
Going back to this part here, I got 0.0018
Okay.
right here. And then I divided that by the 0.010 and I got 0.18. So it's just 2 sig figs. Does that make sense? Because I feel like you got
That's fine. That's fine because you only, well, it'll be 0.0180 if you were keeping the 3 sig figs.
because my calculator only gave me 0.18.
Then you just add the 0 there because you know it should be 3.
So my calculation is just 0.4.
Okay. But then you add you said 0.4.
Yeah, because I did 0.2 times the 0.010 liters. And then I divided that over 0.005 liters, and it just gave me 0.4.
But did you dilute it?
No.
No, so you don't have to divide it by the 0.00 because you didn't have to dilute it.
So okay, I'm confused now. So if I didn't dilute it, I don't divide it by the 0.005?
No, you stop right here.
That's an extra step they did for people that had to dilute it.
Yeah. Am I right?
That is
Yeah,
correct.
you're right, Diana Montoya.
So we
That is
stop
correct.
here. This
Yeah,
is for the
we
people
stop
that,
here.
for Kalinga
Yeah.
that had to dilute their stuff.
Yeah, so some people have to dilute their stuff. Yeah, some people have to dilute their stuff. If you have to dilute your stuff, then you have to do a second. You have to use this equation to calculate your real concentration.
Okay, so then going back, so then my C2 would just be 0.2.
That's correct.
Same as my molarity, right?
Yep.
Okay, goddamn, okay. Jeez.
Dr. Henry,
I need wine.
for the molarity, do we have to add then 98% or do we have to divide
No,
it by?
you multiply because you want to multiply it by, okay, if you did it earlier, right? If you did it here when you had moles, then you don't have to do it to your concentration. If you didn't do it when you had moles, then you can do it to your concentration. It will give you the same answer, right? It's going to give you the same answer that you would have done if you did it at this point.
Okay.
You understand?
Yes.
Because it's multiplication. Okay. Any other questions?
I haven't added the 0.98. So in that case, with my C2, I get
It's
that.
not adding, you want to multiply it, right? You're going to add
sorry. Yeah, I
times
meant
0.98, right? Yes. Okay, because if you add it, that's going to screw up everything.
Dr. Henry, I do have a question. How did we get the, sorry, I'm backtracking, but how do you get the 0.00109?
That's how I calculated my number of moles, right? That came from this equation right here. Okay, because Aaron, are you with me?
Yeah.
Okay, so you got a volume from the gas that was generated, right?
Yeah.
Okay, that volume is what you're going to plug into here to calculate the number of moles of that gas that you're generating. But those number of moles are going to be the same number of moles of acid that we have. Okay?
Yeah.
And so if we solve for N, then we get the number of moles of acid because we know that there's a 1-to-1 ratio for this reaction of gas to our acid. Okay? So when you plug it in here, what did you end up with? And also remember that you have to change your milliliters into liters.
Oh, wait, I didn't see that in red. The N equals V over K. Never mind.
Dr. Henry, so I multiplied I got for my molarity 0.147 times the 0.010 divided by the 0.005, and I got 0.2 or 0.294. Does that sound okay?
That sounds good.
Okay.
So it sounds like all you guys got a molarity of about anywhere from 0.29 to as low as 0.20, right? That range?
Yeah.
Yeah. I got 0.28.
Okay, so it is in that range. Okay, good.
Okay, so is there more mass to this, or this is kind of like it?
There's only one other thing. So the last thing is you want to calculate percent mass of citric acid over your solution. So you know that you have your molarity, right? This is your actual molarity. So that's moles over liters of solution, right? We know that the solution is mostly water. So then we could sit there and say that we can use the density of water, which is 1. So whatever our number of moles, our number of milliliters are, or liters are, it's going to equal, put this down. Density is equal to 1 gram per milliliter of water, right? This guy is moles over liters. So we can calculate our percent mass by using this, and then also by using the molar mass of citric acid. So I want you guys on your own to try to figure this out. So I want percent mass of citric acid. Now, knowing that this guy, molarity, is going to be moles over liters of solution, we're going to assume that our solution has a density of 1 gram per milliliter, which is the same as water. Okay? So you're going to use this, and you're going to use molar mass. Okay? Now I want you guys to try to figure that out. Okay? So did everybody get this down? So let me get a whiteboard, and then I'm going to let you guys talk among each other to try to figure it out. It takes a village. See if you guys can figure it out.
Just one more time on this part. 'Cause this one's like confusing me when I look at it. This part right here.
What part?
This one I circled. N equals. The number looks weird. I don't know. I got that number from.
Dr. Henry,
Okay.
This one.
Dr. Henry,
I understand what you're saying.
I have to step out. My daughter had an emergency. She crashed right now. So if I'm missing anything, I'm gonna probably ask anybody.
Okay, that sounds good. Let me know if everything's okay, okay?
Yes, thank you.
Okay. Okay, that was Michael, right?
Yeah.
Okay, Michael, so this was the number. I was just rewriting the number down here. So it wasn't being really divided by that number.
Okay.
So that was the number that we had calculated, or someone had calculated. So I was just trying to make sure I had it written down right.
How'd you get that calculation? I guess.
What was that?
How'd you get that calculation?
Okay.
We can't hear you.
I said we use this equation over here, right?
Okay, so the 0.0. Okay.
Wait, so I don't know what I did wrong, but I used that calculation and I put the volume. So it'd be 0.045 over the constant. But I did that and I got 0.001836. Like,
Yeah.
So you said you got 0.00186, right?
36, yes.
Did you say 36 or 86?
36, 1836.
18, and then we're doing 3 sig figs. So, and what is your issues with that? So that's what you got for your value, right?
Yes.
Okay, so I don't understand your issues. So then that gives you your number of moles of your.
Oh, so was that n equals 0.00109 an example?
Exactly, yes.
Oh.
I did do your calculations for you. You have your own calculations. Everybody has their own calculation.
Okay, I understood this. I was just worried that I did this example wrong because I got it a different one.
No, it's fine.
Got it. I got it.
You understand it too?
Yeah.
Yeah, I understand it.
Okay, so molarity is not the mass. Molarity is moles over liters. Molarity, okay? Moles over liters. Okay, so that's the definition of molarity. Okay? You'll often see molar as well. That typically means your moles over liters. Okay? Does that help, Brianna? Okay. Okay, so now I want you guys to work as a team to see if you guys can do this. I'm gonna put up a whiteboard. I'm gonna give you a little bit of information, right? So. Okay, so this guy is what my answer was when I did the experiment. So this was the concentration that I got, right? So my concentration was 0.214 citric acid. If I remember correctly, let's see, cheat here. Can't remember the formula for citric acid. So it's C. Sorry, C6. H8O7. Okay,
Yeah,
so that's the chemical formula for citric acid.
Dr. Henry,
Yep.
we are using the molarity, right?
Yeah. Yes, this is the molarity right now. This is the molarity of citric acid. We know that the molarity is capital M means moles. So capital M means moles over liters. Okay. So if capital M means moles over liters, I want you guys to calculate the mass percent of citric acid. We know mass percent is equal to the mass, in this case, of the citric acid, over mass of solution.
And you said our solution was 1 gram, right?
We said our solution is the density of our solution equals 1 gram per milliliter. Now, this here is liters of solution. And this would be moles of, in this case, of citric acid. Okay, so use this value to calculate this. Oh, times 100. Okay. And then I also told you that you're going to need to use molar mass. Of the citric acid. Okay.
This is to solve what again? I'm sorry.
I want you to calculate this.
The percentage mass of citric acid.
Oh, okay.
Dr. Henry, say for like your example, it's 0.214, but for us it would be different, right? It varies on our.
Yeah, it depends on what you have. You guys should have anywhere. So far, everybody has somewhere between 0.3 to all the way down to 0.2.
Okay.
But I want you to do my problem first. I want you to do the work for me because I've done the work for you. I want to sit here and look pretty. Okay, so discuss it among yourselves.
0.214.
So 0.214 times 100. Times.
Dr. Henry, I have a question. So for the massive solution, is it a 10 or a 5 milliliters?
No, in this case, so I want you to start off with this here to get to this. Start off with your value up here. You understand what I'm saying?
Yeah.
Okay, and remember, molarity basically means this. That'll help.
So would it be 21.4?
Okay, so would it be 21.4 for our percent mass?
I don't know if I'm doing it right. So
Because remember, this is milliliters. This is a volume, right? Not moles. So,
Have to make it to liters.
and it's milliliters, you know, for 1 gram of solution.
So 1 gram something.
Okay, so my goal is to get to here from here, starting from here. That's my goal. So let me kind of help you out a little bit here. I'm just going to go ahead and put moles over 1 liter of solution.
Times 100. So I get
Okay.
21.4.
Slow down for a second. Okay, so this here basically means the same thing as molarity. So I have 0.214 moles over 1 liter of solution. So what do I know about the solution?
It's
Density?
in milliliters.
I know the density, right? In grams per milliliter. So I need to change my liters to what?
Milliliters.
To milliliters. So how many
1
how
liter.
many milliliters are in a liter?
1,000.
Okay, so then I'm going to put 1,000 mils here. And I'm going to put 1 liter. Then I can use the density, right? So what is my density?
Your
1 gram per milliliter.
1
1
gram.
gram per milliliter. Okay, so I want to get rid of milliliters. So I'll put 1 milliliter on top.
And then 1 gram in the bottom.
And 1 gram on the bottom. Let's put solution so that we won't lose track of what we're doing. So I'm going to use this as my abbreviation for solution. Okay, so then let's see. So right now, so this guy cancels out with this guy. This guy cancels out with that guy. Okay. So now we have moles over grams of solution. Moles of citric acid over grams of solution. So how can I get rid of moles and change that to grams?
By the molar mass.
The molar mass, that's right. So what is the molar mass of
citric acid?
Citric acid?
192.066.
Okay. So we have 192.066 0.166, and that's grams per 1 mole
You took it, mamita. It's not here.
of C6
Well, check. Where'd you go with daddy?
H8O7
Ask Papa.
of C6 H8O7. Okay, so now this guy cancels out with this guy. And so now we're left with grams of citric acid over grams of solution. So now all we have to do is just multiply, right? Across, then we just multiply that by 100. Because that's what we want, right? Mass over mass of citric acid over mass of solution. So what did you guys get?
Dr. Henry, sorry. For the 1,000 under the 1 liter, it's 1,000 mole? Or?
Milliliters.
Oh, okay. Thank you. Sorry.
4.10995 something. Did I do it right?
I got 0.041102.
Because we multiply 0.214 times 192.066 divided by 1,000, and then you multiply it by 100, right?
Multiply it by, you mean 192, right?
Wait,
So if you go 0.12, what I say, 0.214 times 192 divided by 1,000.
No, you're gonna spill it.
And then after that, it's times 100.
Yep, we need to multiply that times 100. So then that'll be
4.1099.
I got 4.11.
11, yep.
Okay, and that's percent. Okay.
Need to take a.
So we found the mass of citric acid, or we found the mass of the solution?
You found the mass of citric acid in your solution.
Okay.
Your mass of solution, so it's the percent mass of citric acid.
Oh, okay. Okay.
Okay,
Is it 4.11 and then what's that after it?
percent
Percent. Oh,
mass citric acid. Okay.
So that's what we do with our numbers. So instead of the 0.214, then it's our number, and then we do all that stuff.
That is correct. Yep. And that is the last thing you have to do. Yeah.
So for mine, I got 0.056. And then I would times that by 100, right?
That is correct.
Okay.
That's a lot of work. And is that all we have to do?
Yep, that's it.
Wait, sorry, it kind of lagged for me. So all we're doing with this, what you showed us, we're replacing the 0.214 with our data once we calculate it.
That
right?
is essentially it, yes.
Okay.
And we don't have to do no graph or anything, right? It's just,
There's no graph for this one, nope.
oh, thank God.
It's all pure calculations.
So pretty much all that we did right now, we just make it nice and neat and submit it to you.
That is correct.
Okay.
Dr. Henry, we could write this on like paper. We don't have to use Excel. We could just
Yep, you
submit.
could just use a piece of paper, long as it's understandable, yes.
Can we do an Excel for like the colors for the pH?
Yes, you can. You can do that.
And then I can just paste the work onto the Excel, right?
That is correct.
Okay, thank you. I'm gonna head out. Have a good night, Dr. Henry. Thank you so much for your help.
No problem. You guys have a good night.
Oh my God, it's already gonna be 10.
Much. Have a great night. Appreciate it. Good night.
Thank you, Dr.
Have a
Henry.
good night.
Good night.
Thank you, Dr. Henry.
Yep.
Dr.
Yep,
Henry,
have a good night.
can you
Yep.
still? So I'm having a hard time with mine
Okay.
because I got 0.2.
Uh-huh.
So then I do all my calculations, right? So then I do, once I get to the 0.2 times 192.06. Hold on. Okay, my number is not looking great.
And then you divide that by 1,000.
1,000. So I get 38.4132. Then I divide it by 1,000, and then I get 0.0384. Is that right?
0.0384. Yeah, that's fine. Because I have 0.0411.
Oh, I'm looking at the bottom one because you have 4 point.
Yeah, because you haven't multiplied it by 100. Because look at here, mass over mass.
Right. That's okay. I missed that step. I'm like, what am I?
So to get here, you need to multiply it by 100 times 100.
Okay, got it. Let me see. Ah, 384. Oy. Okay, done.
Okay, good.
Okay, long night, but worth it. Thank you, Dr. Henry. I'm out.
Bye.
So just to make it clear, we could submit this in any form, correct, Dr. Henry? It could be Word or handwritten, anything, right?
Anything you want. You could even put it on toilet paper.
Yeah, that's what I'm talking about. By when is this due again?
This guy is due by the 21st.
21st. Okay,
Yeah.
sounds good. Okay, thank you, Dr. Henry.
Okay,
Have a good night.
take care. Have a good night.
Dr. Henry.
Yes.
I missed all that. I joined late.
Ah,
Yeah.
okay. So what part did you get?
Okay, so I mean, I understand it's like what we were doing earlier today about like the molar mass, but how did you get 0.214?
Okay, so you want me to go all the way back to the very beginning?
I mean, I have my, because I'm trying to understand like how like from the
Okay.
'cause from the measurements, right, for the lab, for the 10 milliliters, I got 42, and then for the 5 milliliters, I got 23 and 35.
Okay, so you have, give me your three measurements. So you said you got 42.
42, 23, and 35.
Okay, so you want to take the average of those.
Oh, that's how you got to the given.
Yeah.
So you did, okay, so 42 plus 23 plus 35 divided by 3.
Okay. So then you get what?
33.3. I believe 36 or.
Okay.
Yeah.
So your volume, your V is going to equal 33.3.
Okay, 33.3.
And that's milliliters, right?
Yes.
Okay. So we have this equation, V equals Kn, where V is volume in liters. So we need to change this to liters. How would I change this to liters?
Oh, it would be 1,000 milliliters equals 1 liter.
Okay, so 1,000 mils equals 1 liter. So this is,
I got it. So it would be 0.0333.
okay.
That's
Okay.
my number then.
Okay, so now you want to plug this into this equation and you want to solve for n. K is a constant. K equals 24.5.
Okay.
And that is liters per mole. So if I divide both sides by K, I get VK.
So it would be
Equals N.
it would be
And then you just plug in your value.
oh, okay. So it would be 3 divided by 2.45. Oh no, that's 24.5. So it would be 0.0013. Oh, I want 366. Oh, it would be just
What did you get?
0.001.
0.001.
And then 3. 5.
Okay.
Would be 6 because next to the
36
5.
eggs, that's right. Okay, so then that's your number of moles. And this represents the number of moles of gas that you made, but it's also going to be the same number of moles of citric acid. So your acids is going to be your ascorbic and your citric acids. Okay.
Okay.
So we also know that acids. We know that 98% of these acids are going to be citric, and then 2% is going to be ascorbic. So if 98% is citric, how much of this is going to be citric acid?
That's when I need to do what you did, right? Like.
So what would I do? So if the majority of it is acid, so I'm going to multiply this guy by what? This
Oh,
number here.
that I would. Is that when I need to do the mass percent equals mass of?
No, not yet.
Oh,
Not
no.
yet. We're just, because right now we said, because this is based upon moles. 98% moles is going to be citric acid. Now I'm assuming I have 100 altogether. This represents 100. So if the majority of it is citric acid, what am I going to multiply this number by?
0.98.
That's right. And then that's going to give me how much of citric acid I have. So
Okay, so that would be that would be 0.00132. And that's my my citric acid.
yep. So that's going to be moles of citric acid. That's C7H8. Oh, I think 6. I could be wrong.
07.
07. Okay. Okay. Okay, so now we have our moles of citric acid. Okay, so did you have to dilute yours, or was Did you not have to dilute it?
Oh, no, because it didn't exceed it from the,
Okay, so yours
I
is
did-
perfect. So we'd use this number here, right?
yeah.
And then what was the volume you put this in?
Oh, the volume was 0.0333.
Okay, so no, the volume, not the volume of the gas, but the volume of liquid that you put into the solution, because now we're talking about the acid.
Oh, you mean like the 50 milliliters?
Yeah, how much did you put? Yeah, how much did you put in the tube? Was it 5? Was it 10? Was it?
Oh, it was 10. It was 10.
It was 10. Okay, so molarity is going to be your moles. In this case, it's going to be, of this specific case, molarity is going to equal to the moles over liters of solution.
Okay.
The moles of citric acid over liters of solution.
Okay. Liters of
Okay.
solution.
So we're going to calculate our molarity first.
Okay.
Okay.
Oh,
So you said that you put 10 milliliters.
yes,
So
exactly.
how many milliliters is equal to a liter? Or how many,
Okay.
or 10 milliliters equals to how many liters?
If I'm not mistaken, would be 0.01 liters.
That's right.
Liters.
Okay. So then I plug that in here and I have my number of moles right here. So I have 0.010 liters divided, or 0.00132 divided by 0.00 liters, right? And so this would be my molarity. Okay, so then that's 1, 2. So then that is going to equal 0.132, and we use a capital M for molarity with a line underneath.
Okay.
Okay.
Okay. And that's when I actually do that over 1 liter solution, basically what you did.
Yep, before, exactly.
Okay.
Because I just then changed it to, because this here, and that's of citric acid, right?
Dr. Henry,
Yep,
do you mind looking at my paper before I'm leaving?
sure, I don't mind looking at your paper.
Let me share my screen.
Okay, let me, are you good, Daisy? Or do you?
Yeah,
Okay.
I got it. I got it.
Okay.
Thank you.
Let me save this first.
Yeah, I'm going to take a picture too.
Okay. So now go ahead and share your screen, Helen.
Okay. And then I uploaded the pictures that of my work.
Okay.
So
Yeah, you know you can flip them. So if you click on the image and you go to the corner, I think you can orient them. Yeah. No, yeah. That changes the size, but I think if you go in a corner, you click on the corner, I think you can change, you can flip the image. You can turn it. You go to image options.
mm,
You see it down below, click that.
Yes.
Okay, you see where it says rotate, size and rotation. And you can see rotate 90 degrees.
Oh,
There you
okay.
go.
I
Okay,
see. Okay.
yeah, so if you do that, that'll be fine.
Okay.
It
Okay,
keeps me
thank
from
you.
having to do this all the time, you know.
It
Oh,
must
yeah.
be hard for you to grade that.
Oh, it's a pain, believe me.
Yeah.
But
That's why I
you-
actually take my time to, to fix it because I'm like, oh, it must be so hard for you.
Okay,
Yes,
I'll
that's
do
why it takes me months to grade stuff because of that. Yes.
Okay.
You should take.
Okay.
You should
Thank you,
press
Dr. Henry.
Henry.
Have a good
You're
night.
welcome. You have a good night.
Thank you.
Thank you, Henry. Take care.
Thank you. Bye-bye.
Bye.
Okay, Daisy, are you good? Or did you need that last bit?
If you don't mind, I mean, because
Okay, no, it's okay.
Okay.
I'm still up, so I'll start drinking after this. Okay, so let's see. You okay?
Yeah.
Okay, so this is where we left off, right?
Yeah.
Okay, glad it's still here. Okay, so we have the molarity, and we know that molarity here, we know the definition of it is 0.132 moles per 1 liter of solution.
Liter of
Okay.
solution. Yes.
Okay, so we know that's the definition. Okay, so I'm going to go back to our other page.
Okay.
Okay, so here, what was your number? It was 0.132.
Yeah.
Okay, so you just plug it into this equation here, right? We have moles over liters. So we change our liters into milliliters because we know that the density of our solution is about the same density of water. So that's what we're seeing down here. It's not pretty. So the density of solution is going to be 1 gram per milliliter. So then we can switch that around. So we have 1 gram at the bottom of solution, 1 milliliter up top. So then milliliters are going to cancel each other out. These liters are going to cancel each other out. And so we're left with up top, we have moles over grams. Here we want to try to calculate percent mass. So we want mass over mass. So we want grams over grams. Okay. So then I need to convert my moles into grams. And I do that by multiplying it by the molar mass. So these moles cancel out. We're left with just grams. So if you go ahead and multiply across,
Yeah, I did it.
you got it?
Yeah, I got it.
Does it make sense?
Yeah, it does. I just
Okay.
Yeah, I have do you remember that we talked about I mean that I'm trying my best in the class, so I just hope to bring up my grade.
You'll be fine. You're doing well. I've been impressed with your participation. You know?
Yeah,
You're
I
doing,
got I feel like probably it's not plenty of time, but I have hope that I will bring it up. So far I'm doing so good, to be honest. Like I'm understanding like the molar mass.
yeah. And that's good. That's the important part, that you're getting that understanding. And believe it or not, it's going to pay off in the final by understanding